Okay, now we're going to do a video on related rates here. Okay, so to do related rates, we need to apply the chain rule. Okay, so this is just a fancy way of using the chain rule, and we follow these three steps. We've got what we want to find, what we've got, and what we need to find. Okay, so what we want is here we've got a balloon. Someone's blowing up this balloon. It's increasing in volume, judging by these units, by 3 centimeters cubed per second. So this is the rate at which the volume is increasing. So this is what we've got. We've been given this information. So we've been given dV dt. Now you have to be able to look at the units and be able to tell that centimeter cubed is volume and per unit of time is equal to 3. So we've got that. We're trying to find out what rate is the radius changing at r equals 2 centimeters. So this is what we want. We want the rate at which the radius is changing. So we want dr dt. This is the rate of radius change, yeah, dr dt. So what do we need to get that? Well, let's write out our rule. We want dr dt, our chain rule. This is our chain rule here. Dr dt. We've got dv dt. So that's good for the dt's because we've got dt on the bottom already. But we've got dv on top instead of dr. So we want a dr on the top, yeah? And we want to cancel out this dv, so we need dv on the bottom. So we need dr dv in order. So the dv's will cancel out, we'd end up with dr dt. So if we can find the rate at which the volume is changing with respect to the radius, then we can take the reciprocal. Okay. So what do we know about this? This is a spherical balloon, perfectly spherical. So what's the volume of our sphere? The volume of our sphere. So we're putting all our effort into this bit. So volume of the sphere is, what is it these days? 4/3 pi r cubed. Okay. Now it's easy to take a derivative with this with respect to r, so we can get dv dr. Easy enough. Bring the 3 down the front, 3 cancel out, end up with 4 pi r squared, 1 away from the power. So that 3, multiply the 3, gets rid of this 3, take 1 away from the power, and that's it. Okay, so but I want dr dv, I found dv dr, so let's just give that a flip. That's going to be the reciprocal of that. So 1 on 4 pi r squared. Cool. All right, let's put it into our rule. We'll do it in red. Okay, so dr dt equals dv dt, we know is 3, times dr dv, which is 1 on 4 pi r squared. We want to know when this is 2 centimeters, when r is 2 centimeters. So when r is 2 centimeters, we want 3 on 4 pi 2 squared. Okay, 4, 16. So 3 on 16 pi. What's the units? Okay, dr dt. Radius is in centimeters. T is in seconds. So I've got centimeters per second. That's it. Job done. Okay, so that's the first related rates problem that we've done. Let's do another. We'll do one with a cone. Cone's a classic. Let's get rid of that. We need the space. Get rid of this, but we'll keep our bit. Okay, so what have we got? We've got a cone. Here's our circular end cone. Comes down like this. The whole cone has a height of 15 centimeters and a radius of 12 centimeters. Okay. And we've got some oil in the cone. Oil in the cone, but it's all filled up. It's not all filled up. It's only filled up a bit, but the oil's leaking out. And it's leaking out at a rate of 2 centimeter cubed per second. Okay, So we've already worked out what we've got. We've been given 2 centimeter cubed per second. So 2 centimeter cubed, this is dv dt. So dv dt equals -2. We're leaking out. So the volume in the cone is going down all the time by this much. Okay, so we're leaking out. What do we need to find? The question is, what is the rate? So I'll just shorthand this. What is the rate, the height of the oil is changing, or is falling when the height is 3 centimeters. When the height is 3 centimeters. Oh, it's dreadfully messy, but that's okay. You'll get it. Okay, so what do we want? The rate at which the height is falling. Let's call this dh dt. dh dt. That's what we want. So how are we going to get that? We want dh dt. So this is the bit where we apply our chain rule. Equals. That's what we want. We've got dv dt. Well, this is working out very similar to before because we've got the dt's on the bottom. So we need to cancel out the dv. So we've got to finish with the dv on the bottom. And we want d height on the top. dh on top. So we want dh dv. That means we're going to have to get the volume of this cone, which is a formula we know. Volume of the cone equals 1/3 pi r squared h. But this has another variable in it, r. We want it all in terms of h here because we've got 2 variables here. Well, because we can look at this cone and the oil is always taking the shape of this cone, we're always going to have some similar triangles here, yeah? This triangle and this triangle are going to be similar, okay? So the big triangle, smaller triangle, we've got similar triangles. So we know that these ratios of the height of the oil and the radius of the oil, okay, are going to be in the same ratio as the height of the big cone and the radius of the small cone. So let's just do a little thing over here. We'll say h over r. Now let's do it the other way around because that would be better. You'll see why in a minute, hopefully, if I'm thinking this through. R over h is going to be the same as 12 over 15. Okay, so this r over h divided by this h going to be equal to the same as this ratio, 12 over 15. So 12 over 15, we can divide them both by 3. What do we get? We get 4 over 5, 4/5. Yeah, nice. Okay, so we want to eliminate this r and put it into, we only want h's. So we want to eliminate the r. So we need r as the subject here. R is 4/5 of h. If I did h on r, it's really not that big a deal to get this right. Okay, r is 4/5 h. Sweet. So let's substitute in for r 4/5 h. So let's get rid of the r. Oh, 4/5 h times h. So what have I got? I've got 1/3 pi 16 on 25 h squared times h cubed. So I've got 16 on 75. 3 times 25. Fix that. 75 pi h cubed. Cool. Now I've got the volume just in terms of h. So I'm going to make some space here. A little bit of space. A little bit of space. Here we go. Let's find dv dh. Oh, yeah, dv dh equals times it by 3, and it was 16 on 25 pi h squared. That's cool. I flip it upside down. Let's put it in. I'm going to try and do this really quick. dh dt equals dv dt, which is just -2, times, I need the flip of it, so I need 25 over 16 pi h squared. So I get negative 25 on 8 pi h squared. What do I want? 3 squared, so that's 9. So I get 25 pi equals negative 25 on 72 pi. Let's leave it there. What are the units? DH, that's in centimeters, that's in times centimeters per second. Let's call that done.